Is it live now? Is it live now? Where is it going live then, bro? What the fuck? Oh yeah, it's this live. Where is it going live? Oh yeah, it's live. Fuck it. Okay, we solve this question. So this is basically something hard. So right in range of, so right will be traversing right, or left will be staying at the same position. What do we do now? What do we do now? We should have some condition that, well, let us say, so if s of left is not equal to s of, so s of right. So okay, I'm gonna shift to mouse now. Just a second, guys. What do we do now? If this is happening like this, what do we do? Just a second. What do I do now? What do I do now? What do I do now, guys? Just a second. One viewer watching us. Okay. Yeah. So s of left is not equal to s of right. If that's not equal, okay, we have something called a scale. Okay, we'll have a, and okay, we'll use and here, and oh yeah, yeah, this is not C shit. Okay, is greater than 0. This means that's not equal, but still we can replace a string. So what we want to do is we want to replace right. So s of right uh, is equal to s of left, and left is equal to left minus 1. Okay, yeah. What I've done here is we have just replaced s of right with s of left, and hmm, sorry, it's not left is equal to left minus 1. That's k is equal to k minus 1. So k is equal to, that's k is equal to k minus 1. Okay, replacing right with left when left is not equal to right. What if this comes out of the loop? Oh yeah, that is a problem. If this comes out of the loop, we have two cases more. One is that it is equal to right, or okay, I think we should be switching it to one. No, I don't think. I think we need another if loop inside. If okay, wait. Oh yeah, case greater than 0. We wanna do what? We wanna go at tab space right. Okay. Okay. This is gonna take a fucking so much long. I don't know. This will be completed that time complexity or not. So okay, what does this do? So let's go one by one, guys. Let's debug one by one. So for right in range, it goes from right to left. Sorry, right to left. If s of left is not equal to s of right, basically s of left is uh, a, which is not equal to s of right. We'll go inside the loop and we'll be checking if the k is greater than zero. If k is greater than zero, we're going to be replacing right with the left, and we'll be doing k minus one. Then the loop proceeds further. So this is basically what we do. But the thing right now which I'm confused about is how am I implement the k values here? So max, how can I find the max values here? So let us take an example and let's find it out. I guess that's the only thing which we can do. So we'll take a b itself. So left will be at a, right will be at b, so it's not equal, so b will be changed to a and k is equal to k minus 1, which is 1, and it will go towards a. Okay, if that's been changed, we should do max is equal to max plus 1. I guess so. Max is equal to max plus 1, so that, sorry, max in ngft is equal to max plus 1, so that this works. Max is equal to max length plus 1. But what's the problem here? I don't know what's the problem here. So it is replaced, and now max is equal to 2. So why do you want to do that, bro? Will count max when k is hmm. So do we use elif here? So okay, fuck it, bro. Concentrate. Let me. So A B is here. So okay, let's take some other fucking thing. So A. So right, left, sorry, left, right, and it iterates forward. So it goes to B. K is equal to 1 here. So it goes to B. It replaces it, and the next one is equal. So it should move forward. So it comes here. When the k is over, we should be starting from the position of, okay, what we can do is, oh yeah, we can change the left and right. The replace the length we can put, it's easy for us to traverse further, so easy for us to find the changed character. What do you say, guys? Can we do that? Can we do that? I'm eating Ferrero Rocher, guys. I'll do this with set somehow. I don't think we will. Okay, guys, I don't know. Let me see, bro. Sliding window. They're using dictionary. What the fuck? For right in range also. Count of S of. Okay, I'm adding this. This is equal to 1. Max count is equal to max of. Oh, I hate this question, guys. I fucking hate this question. Fuck. I need the solution.
Hey everyone, welcome back, and let's write some more neat code today. So today we're going to solve longest repeating character replacement. And so this is another problem from that blind 75 list. So we are going to be one step closer to completing the entire list. The link will be in the description to this spreadsheet if you do want to take a look. And hello to the 6 people that are currently viewing the spreadsheet right now. You're going to be in the next video. But okay, so let's get into this problem because it's another pretty fundamental problem that's really good to understand. So we're given a string s and a single integer k. And so basically they tell us that we can choose any of the characters in the string and change it to any other uppercase English character. So in this problem, every character in the input string is going to be limited to uppercase English characters, and we know that there's 26 uppercase English characters from capital A to capital Z. And so basically we can perform a replacement on any of the characters at most k times. So we're allowed to replace k different characters in the string to any other character we want. And what we want to do is return the length of the longest substring containing the exact same character we can get after performing at most k different replacements. So we just want to return that length. We don't actually have to make those replacements in the input string. So in this case, when we take a look at the input string, we have AB, and we're allowed to replace 2 of the characters. So what's the longest substring we could get with the exact same character? Well, we could replace one of the B's. We could basically replace both of the B's with a capital A, and then we get 4 A's in a row, which would give us an output of 4. And we could technically also do the opposite. We could replace the A's with capital B's, and that would give us the exact same result, a length of 4. So I'm going to show you how you can solve this problem in big O of n time, and technically it's going to be big O of 26 multiplied by n, which we know is also reduces to big O of n, but there's actually technically an easier way to do it, or at least a more simple way to do it, which is just going to be a flat big O of n. We don't even need this 26 constant. But this way is actually pretty tricky to get to, so I'll be going over a little bit of it, but this is kind of the main way that you'd want to solve this problem. So let's say we're given an input string like this, and we're given a k value. Now the most brute force way would just be check every single substring, right? And if we were checking every single substring in the entire input array, we know there's n squared substrings, so that wouldn't be the most efficient way to do it. But even if we were doing it like that, what exactly are we looking for? If we're looking at a particular substring, how do we know if this substring is valid? Because remember, at the end of the day, we want to maximize the result, right? The result is going to be the longest substring that contains a single character, and we can make two replacements. So let's look at this substring alone. How do we know if it's valid? Well, which character are we going to replace? Are we going to want to replace the B's in order to make it all be to match A? Or would we want to replace the A in order to match it with the rest of the B's? Of course, we're going to replace the character that occurs less frequently, right? Because the number of replacements we have is limited. So we would want to replace the characters that are less frequent. So in other words, we want all characters in a particular window to match the most common character in that window. So what we're going to be doing is we are going to have a hash map or a array, which is going to take every single character. In this case, we only have characters A and B, and we're going to count the number of occurrences of each character. So for example, if we were looking at this substring, we see that there's 3 B's and we have a single A. So how do we know if this window is valid? What we're going to do is we're going to take the length of the window, which is going to be 4, right? We're going to take the length of the window, right, which we know in this case is 4, and we're going to take the length or the count of the most frequent character. In this case, we know that that's B, and the count of it happens to be 3. So we're going to take 4 minus 3, and from that, we're going to get a 1. Now, what does this value 1 tell us? It tells us the number of characters in our window right now that we need to replace in order to make it match the most frequent character B, right? We have a B here. We want everything to match a B. In this case, we only have an A, right? But it could be possible, like, who knows, maybe that we would have a C over here, right? Or an X over here. And it doesn't really matter what the characters are. We just know that B is the most frequent character in the window, and the other characters that are not B, A and Z, for example, are the characters we want to replace. So we can calculate the number of characters we want to replace just like this. And so we want to replace one character. How do we know if we have enough replacements to do one character? Well, of course, that's our input parameter K, right? So what we're confirming here is that this value is less than or equal to K. As long as this condition is true, that means our current window is valid. That means we have enough replacements to make those replacements in our current window. So this is the main condition that we're going to be checking. The other question is, how are we going to know which character is the most frequent? Well, the brute force way is going to be taking a look at our map of counts, and we know that the max size of this could possibly be 26 because we'd only have 26 different characters. So finding the max character is going to be big O of 26. So that's a little bit more inefficient than we would like, but it's technically still linear time. Like the overall algorithm is still going to be linear time. The last thing that we're going to have to do though is to this equation, we're going to have to add a sliding window technique. So basically what we're going to do is we're going to take our window, start at the beginning, expand it as much as we can, as long as the condition that we mentioned is valid. If the condition is not valid, then we're going to take our left pointer and then shift it as well until the string becomes valid once again. Though is to this equation, we're going to have to add a sliding window technique. So basically what we're going to do is we're going to take our window, start at the beginning, expand it as much as we can, as long as the condition that we mentioned is valid. If the condition is not valid, then we're going to take our left pointer and then shift it as well until the string becomes valid once again. So we're going to have a left and right pointer. So initially left is going to be at the beginning and right is also going to be at the beginning. And also the counts of A
Excuse
and
me,
B
guys.
are initially going to be 0. Now we're going to look at the first character, right? That's where our right pointer happens to be. We're going to look at it. We're going to say, okay, we have a single A, right? We're going to take our count of A and set it to 1 now. So is this window valid? As in, can this window be the exact same character within 2 replacements? Of course it can, right? That's kind of the trivial case, but we would still calculate it. And the way we would calculate it is get the size of our window. Right now we can see the size of our window is 1 subtracted by the count of the most frequent character. In this case, we know the most frequent character is A, 1 minus 1. Is that less than or equal to K? We know K is 2, so of course, this is going to equal 0. 0 is less than equal to 2, which is K, right? So of course this window is valid. That's kind of a trivial case. Next, we're going to shift our right pointer to the next character, right? So now we have a B, so we're going to increment the count of B in our map. So B is now going to be set to 1. In this case, the length of our window is 2. The most frequent character is either of these, right? And the count of that frequent character is going to be 1. So we're going to get 2 minus 1 equal to 1. So this is the number of replacements that we would have to do. And looking at our current window, that makes sense, right? We'd have to replace at least one of these 2 characters. So we're going to ensure that the number of replacements that we need to do is less than or equal to K, which is 2. Of course, that's true. So our window is currently valid. I guess I did forget to update our result. So since this window is valid, the length of the window is going to be set to the result, right? So right now the result is 2. 2 is the length of the longest window that we can get. So that's our result for now. So now let's continue. Next, we're going to shift our right pointer to the third character. So now we get another A. So we're going to take the count of A and increment it all the way to 2. And we're basically going to repeat our algorithm. So once again, we're going to get the length of the window 3 minus the count of the most frequent character. We see the most frequent character is A. So the count of it is 2. 3 minus 2 is 1. Is that less than or equal to 2, which is K? Yes.
The brilliantest. Oh, that's actually, bro. It it gives me all again. Oh, that's actually good. Okay, okay. That's brilliantest answer to the question, guys.
Of course it is. So this
Nice.
window is also valid. We can update our result now to 3. So we found another window even longer. So I'm going to take our right pointer once again and then shift it over to the B. So now we're going to be, since we reached another B, we're going to increment the count of B to 2 now. And so the length of our window now is 4. And the count of the most frequent character is either of these, and that's going to be 2. 4 minus 2 is equal to 2. Is that less than or equal to k? K is 2 in this case. So of course, once again, this condition does hold. So once again, we found a window that's longer than our result. We found a window now of length from the count of B to so once again, so character is B. Of course, it's still true because when you use 2 in a character, that character is B. It's allowed to make earlier, but we're going to have a problem. So now we reached an A. So we're going to take the count of A and set it to 3. So now we have A count 3 and B count 3. So let's take the size of our window, 6, subtract from it the count. We exceeded K, right? We exceeded the number of replacements we're allowed to make. If we wanted this window to be valid, we have to replace 3 characters in it, but we're not allowed to do that. So what we have to do is shrink the size of our window until we are valid. So we're going to take our left pointer and shift it to the right. So now the left pointer is going to be over here. It's going to be at the B. So since we removed this A from our window, we have to decrement the count. I kind of ran out of room, but I hope this is still readable. Window valid. Well, the size of the window now is 5. And the count of the most frequent character is B, and that's going to be 3. Once again, valid. So this is technically a valid window, and I think I forgot to update the result earlier when we had a window of size 5. So the result right now would be size 5 because the longest window we can make is either this window or the window that we had earlier with these first 5 characters. But yeah, and so at this point, we would stop our algorithm because we did find a window of 5 that is valid, and our right pointer cannot be shifted anymore. So this is the general algorithm. So it's a basic it's a fundamental sliding window problem with this particular condition being important. But there's actually one way you can do it without having to look through the entire hash map every time you want to find the most frequent character that occurs. And it's kind of tricky to arrive at this solution, but it's pretty easy to implement once you can figure it out. I'll explain the algorithm at a high level. I don't want to waste too much time on it, but basically we're going to be having another variable, and it's going to be called max frequency, basically the count of the most frequent character at any given time. So basically, for example, if we had A as a count of 3 and B as count 2, we'd say, okay, the count of the most frequent character occurs 3 times, so max F is going to be 3. And so anytime, if we got a B, let's say we incremented our B all the way up to 4, then we'd want to update our max frequency to 4, right? So we'd always want this to be the most frequent character. Now, the one problem is if we're trying to maintain the count of the most frequent character, what happens when we take our left pointer, for example, right, and then shift it, right? When we do that, we're basically removing a character, and therefore we're going to have to update our count map, right? We are going to do that. And if that does happen, right, let's say we took B and then from 4, we decremented it all the way down to 2, for example. Then we'd have to rescan this entire map and then find, okay, what's ever going to increase the result from 6 to another number, like for example, 7. Is actually a lot easier than the visual example that I gave, a lot shorter for sure. So we're going to have a hash map to count the occurrences of each character. And we're also going to have a result, which is going to tell us the longest substring that we can create with K replacements. And we're going to have a left pointer, which is going to be at 0. And then our right pointer is going to go through every single position in the entire string S. So what we're going to do is for the character at position R, we're going to increment the count of it. We're going to take 1 plus whatever the count currently was, count.get this character. And if the character doesn't exist in our hash map, we're just going to return a default value of 0. That's what this function is doing. And so what we're going to obviously do is update our result, right? And we want to set the result equal to the max that it's ever been and set it basically equal to the size of the window. We can get the size of the window. So we're going to take the max of result and the size of the window. The size of the window can be gotten with right minus left plus 1. But before we do this, before we update the result, we want to make sure that the current window is valid. So what I'm going to do is basically say while, and I don't think you would actually need a while here. You could just do if, but I'm just going to do while just because. So while the window is not valid, and we would know that by taking the length of the window, which we have down here. So I'm just going to copy and paste that. The length of the window subtracted by the count of the most frequent character, which can be gotten with max of count dot values, right? We're basically going through the hash map, which could be size 26, and just getting the max value from it. So this is the number of replacements that we have to do. And if the number of replacements was greater than the number of replacements that's allowed, which is equal to k, that's when we would want to shift our left pointer. So we'd want to increment our left pointer. But before we increment the left pointer, we'd want to take the count of the character at the left position and then decrement it by 1. And that is the entire algorithm. After all of that is done, after we've gone through the entire string, then we can just simply return our result.
What the fuck is that? 8, bro? What the fuck? That looks like so simple. Like, so simple, guys. I don't know why, but he's just adding things. Mm. It makes sense, but I don't know. Okay, that's actually good. Count of s of right is equal to plus. But I still can't understand that max length thing. Oh, that's a max. Oh, what do you mean by max count and max? Why is he taking two of the things? Okay, that's a nice algorithm. Actually, it's a nice. Oh, I can't pass a stream. Oh, what the fuck? That's retarded, guys. I can't. Oh, fade. Oh, see, transition fade. Okay. Hmm. we're gonna start this again, and I'm back. I'm back. So it's been like a hour, I guess. Mm, we'll start then. Okay. Hello. So yes, where did we leave? So basically, the thing which we wanna do is like kind of difficult, bro. So what are they saying is we wanna create. So I will create left equal. We wanna give left as 0 and right is right in range then of s. We're gonna have a dict. Well, we have it as dick. Okay. Okay, not gonna lie. Okay. We're having this one right here. Now what we are gonna do? We're gonna iterating through the things, and if we're gonna add everything to that dictionary. So tick off s of height plus equal to 1. So we'll give this as a default if so now I'll be checking if while um how do I get the length? We'll take the solution itself and okay, I can't understand shit here. So we'll try to go with this. So okay, this is def class. I want this. I just want this. Update the character count of that character at the position R. Okay, which we have been doing. So while key condition. Well, okay, this they are doing R. What is R right now? Max count of values. Okay. Okay. Minus left. This one. is greater than k. Oh yeah, we have to dict of this of minus equal to 1 and left is equal to left plus 1. No, how this is. Let's try to run this if this one. Is there? Oh, minus max. Okay. Okay. That's DIC. Then there is another error, and where is it? Yeah, this minus max of. How do you do that? Max of dot get values. This should work now because everything is. Oh, what the left minus a plus 1 minus max of the dot get values of case. This is right, bro. Why is this wrong? I mean, how to some. Wait a minute. Why am I getting wrong? Lecture of 4 hours? No, but previous time also same mistake happened. Now it will work, obviously. Okay. I'm gonna do the same thing here and submit. And move on to the next question of just completed. Today I've just done 2 questions, bro. Diabolical. I should do more. See how to finish at least this binary or stack. Bro, that's hard actually. The thing right now is the main topics are yet to come. They are not even there. They're about to come, bro. So, even true strings S1 and S2 return true if S2 contains a permutation of S1 or false otherwise. In other words, return true if one of S1's permutation is in S2, for example, AB. I can't understand anything. Given I just need the questions, bro. That fuck. What's this? Oh, I can't. Mm-mm.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem permutation in a string. And there's actually 2 solutions to this problem. One is the 26 times n solution, and there's another solution that's actually just big O of n. Now we know that a constant number here doesn't actually affect the overall time complexity, but that being said, I'm still going to focus on the slightly more optimal solution. Because it's a little bit more difficult, but it's also interesting, and it's a pattern that's actually used too. And all we want to do is return true if the string S2 contains a permutation of S1. And we return false if that's not the case. Now, you can get bogged down and really confused with the explanation of this problem, like focusing a ton on permutations, but I'm going to try to simplify this for you immediately without going down too many rabbit holes. And let's actually take a look at this first example. So we see that S1 is the target string. That's what we're trying to look for. We're looking for a permutation of this string somewhere inside of S2. Can we find it? Now, what does permutation mean? Well, we could actually, create a permutation of the string, which would be really complex and annoying. But we see that over here, there actually is a substring of S2, and it's a permutation that matches S1. It's BA, right? The exact same characters, just in a different order, which is perfectly fine. Now, by the way, AB itself technically counts as a permutation of itself. So this string is also allowed. But since you kind of see, what we're really just looking for is there a substring of the exact same size? So this is 2 characters. So we have to look for a substring of 2 characters here, right? We can't just take 3 characters and say that that's the permutation. But, we're looking for a window, same size as this, and it has to contain the exact same characters as S1, just maybe in a different order. Now, does that kind of sound familiar to you? Well, it's the same thing as looking for an anagram, right? We're just looking for the exact same characters. We don't care about what order they're in, right? So it's looking for an anagram, so we can actually use a typical sliding window technique. We're going to look at every window in S2 that's the exact same size as S1. So in this case, length 2. So we're going to look at the first 2 characters, then the next 2 characters, then the next 2, etc., until we find an exact match with S1. Now, if we were actually comparing the exact characters, that would be pretty annoying. The time complexity in that case would, let's say, be n times m, where n is the size of S2, m is the size of S1, because we're looking at every single window. But we can do it a little bit better. We can reduce it to be 26 times n if we use a hash map, because actually in this problem, it's written all the way at the bottom of the description, so it's not on screen, but they tell us that all the characters in both of the strings are going to be limited to lowercase a through lowercase z, so therefore the size for hash map is going to be at most size 26. There's only 26 characters, so as we build that hash map, we're actually going to have two hash maps. We're going to have one hash map for S1, which is going to stay the exact same. We're also going to have a second hash map for S2, which is going to have the characters of the current window that we're at. So every time we create a window, right, each time we shift our window to the right, we're only just adding one character and maybe removing the character that was on the left. And then once we have those two hash maps, we're going to compare them if they are equal, which is a 26 operation, right? There's only 26 characters. And so that's where we get this time complexity from. But there actually is a better way. This solution is doable. It's easy to code up, and you can do so if you would like. But I'm going to show you the slightly more optimal solution, which is actually not even going to have this 26. It's just going to be big O of n. So let's look at the big O of n solution. And it's actually similar to the previous solution we discussed. We're actually going to still have two hash maps, one for S1. So as you can see, we counted the occurrences of each character. We call it S1 count. So we have one A, we have one B, and one C. So we've filled our hash map with the same values. And our S2 hash map is empty because first we're going to set our window here, and then we're going to continue to shift it by one each time. But the difference here is we're not actually going to be comparing the two hash maps together. We won't need to, because we're going to keep track of one more variable. We're going to call it matches. We're basically going to have a little shortcut. Initially, this is going to be set to 0. I'll just create a box for it, even though it's just going to be a single value, but we might be updating it to other values. But this matches variable is basically going to be a shortcut that's going to allow us to not have to compare the entire hash maps each time, which we know in the worst case could be a 26 operation, having to look through every single character of the hash maps. Because this matches variable is actually going to maintain the total number of equal characters in each of these hash maps. And actually, even though I didn't draw the entire map for S1 and S2 in this case, because actually we know that there's A through Z, there's 26 characters, and I didn't actually draw out the entire thing, but we are going to fill in the values in the code, because we know that the rest of the characters in S1 are going to be of count 0, right? And matches is going to tell us the exact number of matches of each character between the two hash maps. So we want to know, does the A count of S1 and of S2 match? If it does match, then that's a +1. If it doesn't match, then that's not a +1, right? And we want to know the number of matches for every single character, and we want to know that initially, right? It could be 26 matches, or it could be 0 matches, right? It could be any value in between. But once we have 26 matches, that means that for some window in S2, and by looking at it, we know that this is going to be the window. We know that this window has 26 matches with this window because they both have a single A character, a single B character, a single C character, and for the other remaining 23 characters, they both have 0 of those characters, so therefore they have 26 matches. That's what we care about, and we can do that with a single variable without having to look through the entire hash map. Let me show you the algorithm to do that. It's pretty straightforward, actually. So first thing we're going to do is actually just look at the first 3 characters of S2 and then fill up our hash map. So we have a single B, we have a single A, and we have a single X. Now you can see that this is what our hash maps actually look like. We have looked at the first three characters, and now what we're actually going to do, for the only time, we are actually going to iterate through both of these hash maps comparing each character. We actually do have to do that at least one time, but it's a single 26 operation. So, and then after that, we'll only have to just iterate through this string. So the overall time complexity is going to be n plus 26, which we know is going to be equal to big O of n. It's definitely better than if we were just doing 26 times n. Okay, so we're going to look at every character. A, they both have one A, they both have one B. S1 has a single C, but S2 does not have any Cs. So therefore, they have two matches, A and B, but C is not a match. Then we're going to look at all the other characters after C, and we're actually going to see that yes, there is a match, right? Because they both have 0 Ds, they both have 0 Es, they have 0 Fs, etc., etc. But then we're going to get to X. Okay, this has a single X, but S1 does not have any X's. That's not a match, but they both have 0 Ys and 0 Zs. So all in all, they actually matched every single character except for C and except for X. Those were the only characters they didn't match. So actually, initially we have 24 matches. Next, we're going to take our window, which was like this, and we're going to shift it to the right by 1. When we shift it, we're obviously removing a character from the S2 window. We're removing a B. Now, as we make changes to the count, we want to know, does it affect?
Okay, this is one of the coolest and nicest questions. Oh shit. My bad, guys. So this is like one of the nice questions which we have ever solved, which is pretty much easy, but I should somehow solve it. So I'm gonna start now. So just a second. Hello, check. Hello. I think I forgot it.
The number of matches. So here we have 1, right, which was equal to what it was supposed to be.
I forgot to turn on. I thought I forgot to turn on that thing. Actually, yeah, it's good. So first we want to create two dictionaries. One for the small string s, one for small string s2. So I'm gonna create like. Wait a second. I'm having a message right now. Okay, let me continue, guys. So what I'm gonna do is, let me create sub as a hash map which contains nothing. Okay, wait, we should contain something, right? Default tick and just initialize to 0, and we have the sub main is equal to default ticked off and as well. Yeah, we use a sliding below, so having on left is equal to 0 and right is equal to 0 as well. While right is less than len of s2. Reading further. Oh, that's a lot tougher, bro. I don't know. What the fuck? Okay, this is a very nice answer for this, bro. What the? But still, if you sort, everything will be changing. No, I don't. How can you sort, bro? That's not even right, lah. So, okay. For I in range of S for J in range of The brute force is pretty much good to solve right now, I guess. Brute force method. Brute force is kind of good. It's like good. What the fuck? Touch. Oh, touch. Oh, can solve in JavaScript. What? In Java, it should be okay. It's the same as C++. It's small. So. Python, bro. Python. So, what do they do here? So, we all know that S1 is the sorted, so S1 is equal to sorted of S1. So, we just do this thing. What it is for in range of S. Now, what we do? So, we're gonna go for J in range of ln of S2. Equal to, and this is the string. String is equal to. We want to slice the string from I to j. I to j plus 1. I to j plus 1. That's the start and the end. Default down the wrong. This is the string, and we're gonna check if string sorted off string then string is equal to s1 return true. Return is- This will always work because wait name S is not defined. Oh, S2. Okay, let's see whether this works. If this is working, we are good to go. Oh, it says accepted, but when we submit this, it obviously should say the timeline. Oh, timeline exceed. What you're doing is we're taking that S1, which is the smallest thing, which we're sorting it basically, and we're taking the another. We can do this in an optimal way, right? There's a lot of ways to do it. Like, we could take the same two pointers, and okay, that's hard. How we keep moving that way. So we have n, which is n square, obviously, and that's an if state. So I think why do we do that? Instead of that, they are saying like, why can't we do something like sorting it in a like a limited way? I know what I'm getting what you're saying basically, but the use is, why don't we do something like um, so that we reduce the number of as soon as solid we know that that particular element should be present here. So why don't we use a while loop r is less than n. Like for example, what I'm saying is why don't we do like this? So left is equal to 0 and this is the right. uh, then now s1, sorry, s1. Then what do you do now? What do you do now is find ranges to uh, we'll start from plus. Okay, fine. Can we give let me try this whether this works or not. Maybe. Okay, this is just from 0 comma I wanna take the length as you can't take that as a step value, right? So that sucks. You can't do that. Basically, you have to take everything, but a lot of reducing this complexity, you can't do that. For iron range, we'll be comparing these things from string to go from left to right. Okay, I don't know. I don't know. Actually, I don't know. I don't mind doing this. That's worst, guys. Haven't solved most of the sums, bro. What the fuck? Like, just solve like a minimal amount of sums. And solve just 3 questions. And that's a good solving of the problem, but still, there are errors in that. Not if I haven't completed this fucking question, bro. Till now, just this. I haven't completed this fucking question, bro. Just one more. I've just done three questions. The last 3 hours. That's fucking diabolical. Oh shit. So what do we do now? What do I do now? I'm gonna just watch the video and just solve it. That's the only thing which I can do right now.
Equal to what it was supposed to be in S1 as well. But now we're now changing it to a 0. So therefore it's not matching with what it previously was matching with. Therefore our matches total is actually going to be updated now to be 23. We're decrementing it by 1. Okay, but we also added a character, a Y. Does this affect our matches? Was this a character we were looking for? Well, let's increment our I by 1, and we see that now it's 1, but what was the Y value in S1's count? It was equal to 0, so now we actually created another mismatch. So actually, the total number of matches is gonna be 22 now. And now we're going to actually shift one more time. So this A is no longer going to be in our window. Now we're going to have XYZ in our window. So we remove the A count is now going to be set to 0. We created another mismatch. So our matches count is now going to be 21, but we added a Z. So our Z count is 1, but the Z count in S1 is 0. Therefore, we created another mismatch. So now our total number of matches is actually going to be 20. Now let's shift our window one more time. Let's chop off this X. So X count is now going to be set to 0. So let's up character. We added this A character at the top. So let's actually increment the number of A's. We went from having 0 A's to now having 1 A, and that's what we were looking for, right? Because
Hello. Solve பண்ணிட்டியா? We are all back, guys. We are all back. Locked. Logged in. So let's see. Um, uh, okay, I can't understand shit in this question, but still I'm watching it so that.
Because 1A is also found in S1 count. So we're going to that's the one little edge case we actually have to look for that I didn't talk about previously, and that's if our S1 string is actually shorter, or actually rather longer than our S2 string, which would make it impossible for us to find a permutation of S1 in S2. In that case, we can just return false immediately, but after that, we can get into our standard algorithm. Even though I was talking about hash maps, we can actually implement these with arrays as well, because we are getting fixed values, lowercase a through lowercase z, and we can convert those characters to be integers, and we can use those integers as indexes of our to array. So initially, I'm just going to set these to be 26 numbers, and each of those numbers is just going to be a 0 for now. We're going to go through every character in S1, and we're going to go, so suppose S1 is maybe 3 characters long. At the same time as we're going through S1, we're also going to go through the first, let's say, 3 characters of S2. So we're going to initialize both of these hash maps at the same time. So let's do that now. So the way we're going to convert these characters, so in S1, we're going to get the character at the ith index, and we're going to use the ORD function. Now, depending on your language, it might be a different function. All we're doing is getting the ASCII value of this character with our ORD function, and we're going to subtract from it the ASCII value of lowercase a. Let's get this right. And this will map to an index. This will map to one of the 26 indexes. And to this, all we want to do is just add 1 to it. And I'm just going to go ahead and copy and paste this line and do the exact same thing for S2. We're going to, in S2 count, we're going to update the count of this character and just increment it by 1. So now before we actually get to our sliding window portion, don't forget we actually have to initialize the number of matches. We're initially going to set it to 0, but let's compare each. each of these maps or arrays, we know that there's going to be 26 spots in the array, so we can actually just hard code that. So now we're going to say to the number of matches, we want to add 1 to it only if S1 count at index I is equal to S.
Okay. Okay, guys, I'm back. I'm so fucking back. Let's go. So, what do I do now? There's nothing. Just a second, guys. Can we eat this? Okay, I'm hearing this question right now. What the hell? There is a fucking dictionary for this. Like, why? What? Oh shit, bro. It's actually good. That's actually good. So this can be solved in a easier manner. Like so easy. Okay, எனக்கு இது தெரியும். Oh, bro, I haven't known this, bro, for a long time. Counter of S2 off until n of 1. Okay. Okay, I have no idea how to solve this. All I can understand is just that fucking bro.
ஹலோ. ம். சும்மா தான் இருக்கேன்.